So this is one example for nanotube. So though the picture is shown very big picture, but it is very of small, tiny shape. And these are few examples for nanostructures. So noble metal nanocrystal with cyclic twinned structures. So these are different sizes of nanomaterials like 10 nanometer, 100 nanometer. The star structure is 100 nanometer, and this octagon kind of structure is of 200 nanometer. Similarly, the star structure is of 100 nanometer. So these are all having different sizes and having different applications. Then when it comes to next slide, few more examples. So not only 100 nanometer, 200 nanometer, 10 nanometer, but is also available with as a grain, nano grain, like a powder. Okay, so nanomaterials that has unique novel properties. Now we are looking into what sort of properties is the nanomaterials are having. So at nanometer scale, what sort of properties generally the materials will have? Let us see. So generally, nanomaterials are formed incorporating structuring of nanoparticles. So generally, nanoparticles are again subdivisions of materials. Subdivision in the sense up to nano sized crystal materials. So these are like the nanocrystal materials or nanopowders or nanotubes, a sequence of nanoscale of C60 atoms arranged in a long, thin cylindrical structures. So nanotubes, the very medium slide of first example, you might have seen nano tube that is strong mechanically and very pure conductors of the electric current. So applications of the nanotube includes resistors, capacitors, and inductors and diodes. So the nanotube is made with the kind of polymer, and because of the resistive property, it can be stretchable to any layer, such that the application of such layers will be resulting either the behavior of a resistor or a capacitor or inductor according to requirement. Based on the orientation of the nanotube, not only orientation, based on the thickness and thinness, we can get different kind of behavior of the device. And these are few examples of like nanomaterial properties. So catalytic property. So generally we can see the properties under chemical, under mechanical, under what do I say, biological properties, but very few electrical properties and mechanical. All this only few considered in this PPT. So catalytic property, better catalytic, the nanomaterials have a better catalytic efficiency through higher surface to volume ratio. And when it comes to electrical, these nanomaterials have good conductivity in ceramics and magnetic nano composites. And instead of big scale materials, we can use nano that increases electrical resistance in metal. Similarly, under magnetic applications, so the properties like increased magnetic coercivity up to critical gain size and super magnetic behavior. Similarly, when it comes to mechanical field, so the nanomaterials improves hardness and toughness of metals and alloys ductility and super plasticity of ceramic. So not only the easiness of making the nanomaterials for mechanical devices, whereas their outcomes or results are very flexible and will be improved compared to large scale materials. Similarly, optical field, if you see the properties like spectral shift of optical absorption and fluorescent properties, increased quantum efficiency of semiconductor crystals. And spherical, that is another field in which the properties of nanomaterials have selectivity, high selectivity, and hollow spheres on specific drug transportation and controlled release. So that is all spherical in medical applications. Similarly, biological field, the properties like increasing permeability through biological barriers. The barriers are like membranes, blood brain barrier, etc. And is also biocompatibility, one biological material to other. So biocompatibility also can be observed with respect to nanomaterials. Now, um, when it comes to properties individually into different fields like physical properties. So the physical properties basically concentrate on size, the shape, specific surface area, aspect ratio, and agglomeration, aggregation state, size distribution. So these are all matter when a nanomaterial is made for the application of electrical or mechanical, and basically the structure of the material, and including crystalline and defect structure and solubility. So, and when it comes to chemical, the properties of nanomaterial will be concentrating on structural formula or molecular structure. Structural formula in the sense like what kind of nanomaterial, like silver bromide. So the components, the combination together, what sort of compound to be build the nano compound. So like that, structural formula is one of the property. Molecular structure, molecular structure in the sense how many atoms with which the nanomaterial is compounding, like that. And composition of nanomaterial, degree of purity and impurity, additives, and phase density. Phase density is like when two materials are combined, they have the different shape. The combination of two atoms may result in third atom with different phase. So phase identity, then surface chemistry, composition, charge, tension, and then reactive sites, physical structure, photocatalytic properties, zeta potential, and then hydrophilicity, lipophilicity. All these are matter when it comes to when nanomaterial is used under chemical field. So generally, some common type of features of nanomaterials are look into, which are like size. Basically, the nanomaterial size will be limited to the nano level of 1 to 100 nanometer. Then it should be chemically active. So, with respect to various applications, like whether it is physical application or chemical application or biological, so the nanomaterial should be active in those particular environment. Then, and it should be active to color change, to identify, for example, like using some material, using some what do I say, to identify cancer cells. So based on the color, based on the size may change, the color may change, nanomaterial color may change. So all these during application, it should be very proactive. Then it should be strong and hard and ductile. So these are general characteristics of a nanomaterial with various applications it should follow. Then depend upon the size of nanomaterial. Uh, Generally, nanomaterials are properties under optical can be represented like light absorption, or scattering the light based on the size of the materials. So if it is the material, nanomaterial is of less than 20 nanometer, the material property is absorption. Whereas if the nanomaterial is size is of greater than 100 nanometer, then with respect to optical, the nanomaterial behavior is scattering. So based on the size, the behavior is changing if you observe that. Less than 20 nanometer, absorption. If it is greater than 100 nanometer, scattering. So, because why scattering, in the sense the thickness of nanomaterial will be more so that absorption cannot happen. Whereas when it comes to 20 nanometer, because it becomes thin, so the optical light, when it falls onto the thin material, absorption will take place. So that is the difference where you can observe. Similarly, nanomaterials will show color change. At bulk level, they are looks like opaque, but when the tiny nanomaterial, if you observe that, they look like a transparent material. So similar example like copper and silicon, and similar in the case of gold, 50 nanoparticles show green color. That means the size of the particle is very less. During that time, it appears like green. Whereas if the particle size is increased to 100 nanometer, it shows like or looks like orange. And if it is greater than 100 nanometer, generally that is the one which we see generally with our eyes, that is color yellow. So like that, color or application varies with respect to the size of the nanomaterial.